Okay, our third section of our weather and climate unit is layers of the atmosphere. So, we're going to get started. Imagine taking a trip upward into the atmosphere in a hot air balloon. You begin on a warm beach near the ocean at an altitude of 0 kilometers above sea level. You hear a roar as the balloon's pilot turns up the burner to heat the air in the balloon. The balloon begins to rise, and Earth's surface gets further and further away. As the balloon rises to an altitude of 3 kilometers, you realize that the air is getting colder. As you continue to rise, the air gets colder still. At 6 kilometers, you begin having trouble breathing. The air is becoming less dense. It's time to go back down. What if you could have continued your balloon ride up through the atmosphere? As you rose higher, the air pressure and temperature would change dramatically. Scientists divide Earth's atmosphere into four main layers, classified according to changes in temperature. These layers are the troposphere, the stratosphere, the mesosphere, and the thermosphere. The four main layers of the atmosphere are shown in Figure 9. Read on to learn more about each of these layers. This is Figure 9, so you're able to see the layers of the atmosphere here. You have the troposphere, the stratosphere, the mesosphere, and the thermosphere, which continues all the way up. Now, the troposphere. You live in the inner or lowest layer of Earth's atmosphere, the troposphere. Tropo means turning or changing. Conditions in the troposphere are more variable than in other layers. The troposphere is the layer of the atmosphere in which Earth's weather occurs. The depth of the troposphere varies from 16 kilometers above the equator to less than 9 kilometers above the north and south poles. Although it's the shallowest layer, the troposphere contains almost all of the mass of the atmosphere. As altitude increases in the troposphere, the temperature decreases. On average, for every 1 kilometer increase in altitude, the air gets about 6.5 degrees Celsius cooler. As the top of the troposphere, at the top of the troposphere, the temperature stops decreasing and stays about negative 60 degrees Celsius. Water from here forms thin, feathery clouds of ice. The stratosphere. The stratosphere extends from the top of the troposphere to about 50 kilometers above Earth's surface. Strato means layer or spread out. The stratosphere is the second layer of the atmosphere and contains the ozone layer. The lower stratosphere is cold, about negative 60 degrees Celsius. Surprisingly, the upper stratosphere is warmer than the lower stratosphere. Why is this? The middle portion of the stratosphere contains a layer of air where there is much more ozone than in the rest of the atmosphere. Recall that ozone is the three-atom form of oxygen. When the ozone absorbs energy from the sun, the energy is converted into heat, warming the air. The ozone layer is also important because it protects Earth's living things from dangerous ultraviolet or UV radiation from the sun. The mesosphere. Above the stratosphere, a drop in temperature marks the beginning of the next layer, the mesosphere. Meso means middle, so the mesosphere is the middle layer of the atmosphere. The mesosphere begins 50 kilometers above Earth's surface and ends at an altitude of 80 kilometers. In the outer mesosphere, temperatures approach negative 90 degrees Celsius. The mesosphere is the layer of the atmosphere that protects Earth's surface from being hit by most meteorites. Meteorites are chunks of stone and metal from space. What you see as a shooting star or meteor is a trail of hot glowing gases the meteorite leaves behind in the mesosphere. And lastly, the thermosphere. Near the top of the atmosphere, the air is very thin. At 80 kilometers above Earth's surface, the air is only about 0.001% as dense as the air at sea level. It's as though you took a cubic meter of air in the sea level and expanded it into 100,000 cubic meters at the top of the mesosphere. The outermost layer of Earth's atmosphere is the thermosphere. The thermosphere extends from 80 kilometers above Earth's surface outward into space. It has no definite outer limit, but bends gradually with outer space. The thermo in thermosphere means heat. Even though the air in the thermosphere is thin, it is very hot, up to 1,800 degrees Celsius. This is because sunlight strikes the thermosphere first. Nitrogen and oxygen molecules convert this energy into heat. Despite the high temperature, you would not feel warm in the thermosphere. An ordinary thermosphere would show a temperature well below 0 degrees Celsius. Why is that? Temperature is the average amount of energy of motion of each molecule of a substance. The gas molecules in the thermosphere move very rapidly, so the temperature is very high. However, the molecules are spaced far apart in the thin air. There are not enough of them to collide with a thermometer and warm it very much. The thermosphere is divided into two layers. The lower layer, called the ionosphere, begins about 80 kilometers above the surface and extends to about 400 kilometers. Energy from the sun causes gas molecules in the ionosphere to become electrically charged particles called ions. Radio waves bounce off ions in the ionosphere back to Earth's surface. Brilliant light displays, such as those shown in Figure 10, also occur in the ionosphere. In the northern hemisphere, these displays are called the northern lights, or the aurora borealis. Auroras are caused by particles from the sun that enter the ionosphere near the poles. These particles strike atoms in the ionosphere, causing them to glow. Exo means outer, so the exosphere is the outer portion of the thermosphere. The exosphere extends from about 400 kilometers outward for thousands of kilometers. Okay, that is the end of our section 3. I hope you enjoyed it.